Hello viewers, welcome to my channel and thank you for watching the videos. In this video I will discuss question 4A of mathematics paper 1 of UPSC 1992, and this question is related to calculus. Here we have given y is equal to e to the power ax cos bx, and we have to prove that y2 minus 2ay1 plus a square plus b square into y is equal to 0, and hence expand e to the power ax cos bx in powers of x and deduce the expression e to the power ax and cos bx. So we can expand e to the power ax and cos bx directly also, but here we will use this expression which is recurrence relation we will get, and by using that we will expand these. So directly we won't do because this question. Now we put value of x 0 in y and we get y 0. So we get this as 1, this as 1, x is 0. When we put e to the power 0 cos 0, both are 1, so 1. When we differentiate it we get y1. It's a product of two functions, e to the power ax cos bx. So we have the formula differentiation of first function into second function plus differentiation of second into first function. This is what has been written here, e to the power ax into a and cos bx as it is, e to the power ax as it is, and differentiation of cos bx is minus b sin x sin bx, and when we put x is equal to 0 this becomes a. So y1 at 0 is a. Now y2 we differentiate this term and this term, this with e to the power ax along, we get this expression. Now in the question this has been given y2 minus 2ay1 plus a square plus b square into y. We substitute values of y2, y1 and y in this and we see it comes 0. Now we need to have general term, that is recurrence relation for yn, so we differentiate it n minus 2 times further and get that on left hand side it becomes yn and right hand side one time differentiation is already there, so 2a yn minus 1, and this is minus a square plus b square yn minus 2. This is the recurrence relation which we will. So y0 is 1, we have already done in the previous slide. y1 0 is a, already done. y2 we have calculated, put 0. So now expression we are using, instead of the whole thing we are using this recurrence relation, and in this recurrence relation we know these two terms already. So y1 0 y0 we know and we got this expression. Now for y3 0 we are using again recurrence relation and we got it. So now we can easily write it, y4 0. Now general will be yn 0 where r takes value 0 to n by 2 less than equal to, and the coefficient n 2r, and coefficient of what, a to the power n minus 2r, b to the power 2r. Let's check how we are writing. Let's say n is equal to 4, the last expression, this one, n is equal to 4. Then what happens that when we take r is equal to 0, then minus 1 to the power 0 gives you 1, and n 0 is 4, and n 0 means factorial 4 upon 0 factorial and 4 minus 0 factorial, that is 4 factorial. So this becomes 1 into a to the power 4 minus 0, so a to the power 4, and b to the power 0, that is 1. So this comes a to the power 4. Now when we take r is equal to 1, we take r is equal to 1, that is much better. So that is minus 1 to the power 1, that is minus sign, and n is 4, and this will be 2, 4 2, and a to the power 2 and b square, a square b square. So this will give second term, and this comes minus factorial 4 upon 2 factorial, and then 4 minus 2, that is 2 factorial, into a square b square, a square b square. So this gives us that. Now we will see the coefficient of a to the power n minus 2r and b to the power 2r in yn 0. So the expression yn is equal to 2a yn minus 1 minus a square plus b square yn minus 2. So let's see the first term, that is 2a yn minus 1. So in this 2 is there, so we have taken 2 and minus 1 to the power r, because plus minus sign is there, alternate signs are there, so when r is 0 we get 1 here, plus sign, and then next we will have negative sign. So a to the power n minus 2r is equal to n minus 2r is equal to a in the first term. It means n minus 2r is equal to 1. We can write down n minus 1 is equal to 2r. It means out of n minus 1 we have to take 2r terms, but b to the power 2r gives 2r is equal to 0. So we have here that out of n minus 1, 2r items we have to take. Then comes minus sign for second term. Second term is minus a square yn minus 2. So then it is minus 1 to the power r, and it gives us, because when r is 0 it gives 1, and then the total term becomes minus. And next here we have this n minus 2 2r. So for this I would like to say it is because n minus 2r is equal to 2, because a square is there. So n minus 2 is equal to 2r, and b square term is not there, so 2r is 0. So here also we have to take n minus 2 out of n minus 2 objects. 2r objects we have to taken. Earlier it was n minus 1 2r, here n minus 2 is equal to 2r. Now third term is n minus 2r is equal to 0 there in third term. N minus 2r is 0 and 2r is 2, because n minus 2r is equal to 0 because no term of a, but from b to the power 2r it comes 2r is equal to 2. So what we can write, n minus 2 is equal to 0, and from here we can write down 2r minus 2 is equal to 0. It means n minus 2 is equal to 2r minus 2. So we are writing the same thing here, n minus 2 we are taking 2r minus 2. And why we have taken this minus 1 to the power r minus 1, because from here we get r is equal to 1 and r minus 1 is equal to 0. So from here we, otherwise earlier we had here r is 0, in this also and second one was also having 2r is equal to 0. So here we have taken r minus 1. This is one way of understanding. You can find another way, but so now we have taken minus 1 r common, 2 is there, n minus 1 2r. Second is, this is common, so minus sign is here, this as it is. These two terms, one we have subtracted, another added, same term. So n minus 2, 2r minus 1 subtracted and here added. And from here, because we have taken minus 1 to the power r common, so here minus 1 is remaining, so minus minus gives us plus sign, and this term is as it is. Now we know the formula. Here we use the formula NCR plus NCR minus 1 is equal to n plus 1 CR. So that formula has been used in the first two terms. Here in these two terms, and in these two terms again, n is here n minus 2 and r is here 2r. So that way we will get this formula by using NCR plus NCR minus 1, we will get n plus 1 CR. So again we will use the same formula here also, and we get this expression. So this is the coefficient. Now by the Taylor-Maclaurin's formula, we know this is standard, sigma n is equal to 0 to infinity yn 0. Now we put b is equal to 0, we get the expression for e to the power ax, y is equal to e to the power ax. Just write a few terms and you will see that this comes e to the power ax is equal to this much. And when we put a is equal to 0, a few terms please write for e to the power ax cos bx, and then you will see that this expression has come for cos bx. I hope